In this video, I'm just going to talk a little bit about MSA. MSA stands for mannitol salt agar, and it's evaluating the ability of the microorganism to be able to use the sugar mannitol. If it does use the sugar mannitol, the plate is going to turn bright yellow, and if it does not, then the growth on the plate is going to remain pink, or it'll grow the color that it usually grows on agar. So, because it grows different colors in the presence of different microorganisms, we call this a differential media. This is also a selective media. So selective media means that it selects against the growth of certain microorganisms. We typically use MSA agar in order to evaluate skin or wound cultures, respiratory cultures, and that type of stuff. We can do nasal swabs for the presence of Staphylococcus aureus or MRSA, and it's typically more so for the identification of staph-related species. So, staph-related species tend to grow on the skin where we have a high salt concentration, so they can handle a lot of salt. Not many other organisms can handle that amount of salt. So the high salt concentration in here selects against the growth of most other organisms. So here you can see Staph aureus growing on the plate, and you can see colonies have been isolated. This went through the streak plate method, and we can see perfectly isolated colonies. Staphylococcus aureus turn the plate yellow, which means that it does ferment mannitol, and it's growing on here, which means it can grow in the presence of that high salt concentration. This is E. coli on the plate. You can see that there is no growth on the plate, and because there's no growth, we can't mark this based on mannitol fermentation. This is just indicating that this is a negative result for growth. E. coli can't grow in the presence of this high salt concentration on the plate.